Okay, I thought about it again. I said, you know what, I'm going to just graph one more for you. So here we go. We've got this log function. We're asked to graph it. And when we look at that, we kind of go, okay, wait a minute. This is a big mess, right? But the big thing that we're going to do right now is we're just going to say, hey, look, what is the base? So if you see log without a base, what's the base? You remember, it's 10, right? If it's ln, then the base is e. If it's just log, it's 10. And if it said log 5, we would know it already. So if it's not there, it means 10. Therefore, I need to look at 10 to the x. I need to make a t-table out of 10 to the x. I'm going to plug in just three numbers, -1, 0, and 1. So 10 to the -1 is 1/10. 10 to the 0 is 1. And 10 to the 1 is 10. Now I take these, in order to look at the graph of log base 10 of x, not this guy, but log base 10 of x, I'm just going to flip the ordered pairs. So it's going to be 1/10, -1. It'll be 1, 0, and it'll be 10, 1. So now what I do is I can come over here, and let's see, my x values go out to 10. Let me move this a little bit. My x values go out to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My y values go from -1 to 1. So at 1/10, I'm at -1. At 1, I'm at 0. And at 10, I'm at 1. So I have this log function. Looks like this. Remember, it drops down, has a vertical asymptote like that. So this is the graph of log base 10 of x, or if you wanted to, you could just call that log x, right? We don't need to write the 10. And now we're not done, because now we have some shifts and stuff involved. So what I'd like you to do is look at what we have here, and I want us to rewrite it. That's the same as negative log of x minus 3 plus 2. I just moved the 2 back here. Now, what is this going to do? The 3 is being subtracted inside the log, so that's going to move our thing to the right, opposite of what you think, by 3. This negative in front is going to reflect it over the x-axis, right? That's a reflection. And then this guy right here is going to move everything up by 2. So let's do that one piece at a time. I'm going to move every single point to the right 3. So this point comes to the right 3. 1, 2, 3. I have a point. It gets reflected over the x-axis, so instead of being down 1, it comes up 1. And then it moves up 2. So I move it up 2. There's my point. I'm going to kind of just go back through that. I moved that point to the right 3. I reflected over the x-axis, and then I moved it up 2. So I'll erase some of this stuff here so we don't get lost. Now I'm going to take this point to the right 3. 1, 2, 3. Right? It's right there. Now reflecting it over the x-axis doesn't change anything because it's on the x-axis. And then I'm going to move it up 2. 1, 2. So it goes here. Okay, so that's that point. I can kind of just get rid of it here. And then take my last point here. I move it to the right 3. Okay, reflect it over the x-axis, brings it down below. And then move the whole thing up 2. Up 2 would put it right back where it was. Boom, right there. It's kind of weird. Right 3, reflect over, and then up 2. Puts it right back here. And now you can see the graph of this. Looks like this. Okay, it comes down through there. But the question is, where's the vertical asymptote? Well, remember, the only thing that's going to affect a vertical line is any shift to the left or right. So what happened was this whole function moved to the right 3. So our vertical asymptote that used to be here moves to the right 3. 1, 2, 3. Now my graph is not very good here. But you can see it turns up here like that, and that would be our new vertical asymptote. So this function right here is the graph of this function.